That's false. You're only in one of them, right? The second one? Yeah, I suppose. All right, so a couple of standard situations, but then some mathematical ones. 3 plus 5 equals 8, and 5 is less than 7 minus 1. True or false? True. Both parts are true, right?
What?
What? All right, 10 plus 2 is not equal to 12, and 8 minus 3 is greater than 0. So one part's false, one part's true.
So it's false.
So it's going to be false. All right, so first part false, second part true. Now, in the case of number 1, it was the first part was true and the second part was false. Both cases gave us false. All right, so in number 3, both parts were true, and that's where we got a true result. So for and, it seems like there's a pattern here. Now for number 5, 3 is less than 5 plus 4, or 6 plus 4 is equal to 9.
False.
Okay, so this part is true, right? Now this part is false, correct?
Yes.
So this, or, we actually use a symbol for that. If we're using notation, it's a V. V for or. All right, so now let's go back to number 2. Right now I am in math class, true, or I am in English class. Well, that's false, but somehow we ended up with a true, right? So how is this any different?
So you have to, how do you end it?
Well, you all told me true for number 2. I mean, you want to walk that back? Is that something you now disagree with? All right, this is the same problem, except this has mathematical terms in it. This one has, real life stuff. All right, but the idea here is that if either part of it is true, they call it a disjunction, an or sentence. If either part of it is true, the whole sentence is true. All right, so I am either standing here right now, or I am sitting in my car. What do you say about that? True or false?
True.
It's a true statement, right? One or the other? Yeah? I'm either here or there. I've satisfied one of the conditions.
But isn't it false? No.
You're either wearing a white shirt or a green shirt.
So it's true. One of them is true.
Well, any part of it's true, I'm right.
I'm actually thinking
If I went down the hall and I told the student, I was like, go check out Nicole right now. She's wearing either a green shirt or a white shirt. I guarantee you it's either green or white. And they come back, they see that you're wearing a white shirt. They're not going to be like, you're full of crap, dude. They're going to say, oh yeah, you're right. Now, if I said she's wearing a red shirt, a green shirt, a white shirt, a black shirt, a blue shirt, whatever, any of those possibilities, then the student's going to be like, I'm not even walking down the hall. You just named every color in the rainbow. Like, she's probably wearing one of those. Right? So as long as I satisfy one condition in an or sentence, that's all I need. All right?
Wait, that's so confusing. Oh my God.
It is logic. Logic is very confusing. But it's the foundation of everything. All right, well, the next one's very similar conceptually. First part, is that true? 16 minus 20, is that greater than 1? No. Is 5.5 plus 4.5 equal to 11? No. So this one's just going to be false. All right, so basically what we're getting from this idea, I mean, this is what the follow-up is. When two declarations in a sentence are separated by and, they both have to be true in order to be true. All right, so in number 1, again, we have a symbol for and also. They were both, or one part of it was false. The first part was true and the second part was false, so we claimed it was false. All right, but in number 3, the first part was true and the second part was true, so it's true overall. All right, in number 3, so I'm just backfilling with notation here to make it a little bit more clear, hopefully. The first part was true And the second part was the one, the first part was the one that was false. And the second part was a true statement, but it still didn't give us a true sentence overall, right? So if both parts are true, then the sentence will be true. In order to be false, both parts have to be false. All right, so again, this and corresponds with that upside down V for some reason. And the V corresponds with, that's how I remembered it back in the day. It's almost an A. That corresponds with and. The other one has to be or. All right. I won't get into the math names for these things because they're a little confusing, and also for a different year. Although we might do some of it this year because we do some probability and statistics at the end of the year, and it relies on your understanding of logic. By the way, if you can somehow work towards, and I'll try to help you with this, but developing a logical mindset in math class, it really does go a long way. The people who naturally have been good at math and continue to be good at math do so because they're logic-minded. All right, they tend to think along these lines. Not the notation, but when I say something like, in order for an and sentence to be true, both parts have to be true, a person with a logic mindset would say, yeah, of course. A person who doesn't have one yet would say, whoa, where's that coming from? We need to talk. All right, so we're working towards it, but if you can get there, then math can go from an area of weakness to an area of strength. And that, I can't emphasize that enough. All right, and these ideas come into play when we're dealing with compound inequalities. All right, compound inequalities are taking two inequalities and smushing them together. All right, so can you think of a number that is less than 3 and also greater than -1?
2.
So 2? Okay, 2 sounds good. 0. We got a whole bunch of possibilities, right? Now, a number that is less than 3 and also greater than -1, so we're going the other way, right? Oh, wait, no, this is actually the same thing. So 0. I was thinking of a different question, sorry. Yeah, you have a bunch of possibilities, right? You could also set a 1, 1.5, 1.42, -0.5, -0.25, a lot of possibilities. Right, so what we want to do is graph all the solutions where x is less than 3. All right, so what I'm going to do is right off on the side here, I'm just going to do a little quick sketch of a number line. So here's 3, and here's -1. I want all the values that are less than -3 while also being greater than -1. So that's what the number line would look like generally. I mean, I'm not good at drawing, so. Should you draw it? Yeah. Anything I put down on paper is at least worthy of consideration of being in your notes. Using the number line graph all its solutions. So what I'm looking for is any values that coincide between the first set and the second set. So could we not just simplify that to say, I'm really just going from -1 to 3? Because that's the set of values that start here and end here. That's the overlap between the two sets. It's the first set and the second set. When does the first set and the second set end up having the same values? All right? We're looking for truth. I'm looking for true and true. So in order to be true, I have to be greater than -1, and I also have to be less than a +3. In order for that to happen, it has to be a number in that interval. Now, in terms of the compound inequality, this is actually kind of nice because when you have an inequality that's between two numbers, you could actually just write the inequality itself the same way. So I'm starting with a -1. That the x value, whatever it is, has to be between that -1 and the 3. But I can't be equal to the 3, and I can't be equal to the -1. So I'd write my inequality like that. But even better than that is interval notation, and this is why we learn it. You definitely want to get this down. Starting at -1, going to 3. I think that's a much more convenient way of writing this expression than using the inequality notation. All right, they both mean the same thing, though.